So this is going to be 2.2 for my pre-algebra series, and this is going to be solving equations using the multiplication property. So we're going to solve some equations that look, maybe they're reduced to something that looks like maybe 2x equals 8, 3x equals 7, or maybe our initial equation looks like 5x minus 3 equals 8x plus 11. So we're going to solve some equations that look like this, these linear equations. And this is going to build off of 2.1 ever so slightly. So at the end of 2.1, I said, what if we have this equation 4x plus 7 equals x minus 2? Now, the way everything in 2.1 kind of worked out nicely. And what I mean is, okay, so to do that, what we would to use the procedure from 2.1, we would combine, we would put all of our terms involving x on one side of the equation and all of our constants on the other. So I'm going to put the x's all on the left side. So to do that, since I've got a positive x on the right side, I'm going to subtract x from both sides. And I'm just lining them up again just to combine my like terms. So on the left side, 4x minus x, that's just going to leave me with 3x. And I still have plus 7 left over. And then on the right side, my x minus x, well, those cancel out. I would just be left with the negative 2. So again, I'm just subtracting x from both sides of this initial equation. Now, I want to get the x all by itself, so what I'm going to do next is, since I've got 3x plus 7, I'm going to subtract 7 from both sides. And that's going to leave me with 3x on the left, negative 2 minus 7, that's negative 9 on the right. Now, everything in the previous section in 2.1, once we did these, we always ended up with x equals some number. Maybe it was x equals 7 or x equals 10 or whatever it was. But notice in this case, we've got a coefficient in front of our x, and we didn't have that in any of those examples in 2.1. So now the question is, how do we get rid of that 3 that's being multiplied by the x? Well, again, what we want to do is we want to think about inverse operations. We want to undo the fact that we're multiplying x by this number 3, right? Well, what undoes multiplication? And what I would like to do, again, I would like to have just x by itself on the left side. I would like to do some arithmetic and just be left with x equals some number, and then I'll be done. That's my goal. So what do we do in between there? Well, since we're multiplying both sides by 3, what I can do is I could divide both sides by 3. Now, dividing both sides by 3 is the same thing as multiplying both sides by 1/3. Okay, so what I'm doing is I'm multiplying both sides of my equation by a constant. Well, 1/3 times 3, or equivalently 3 divided by 3, that's just going to leave me with 1x, and that's what we wanted on the left side, or on one side of the equation. And then on the right side, well, negative 9 times 1/3, that would just simply equal negative 9 over 3. And negative 9 over 3 is going to leave me with negative 3, and that is my solution. So the moral of the story is, what's going to happen is, let's just revisit this step. 3x equals, what did we have? We had 3x equals negative 9. Whatever number is being multiplied in front of the x, whatever the coefficient of x is, what we're going to do is we're going to divide both sides by that number, and that's how we'll get rid of it. Or equivalently, we'll multiply by 1 over the number. And we'll do this in a bunch of examples. That's the only new step in this compared to the last one. So we'll go through this a little quicker after we do a few. Okay, so it's called the multiplication principle, or excuse me, the multiplication property of equality. So it says if we have an equation, so if we have two things that are equal, it says what we can do is we could multiply both sides of that equation by some non-zero number c. That's what it says. So what I like to do when I go to solve equations, and again, we just saw this, what I like to do is I like to combine all of my x's, and then I like to combine all of my constants. So again, we already saw this one, 4x plus 7 equals x minus 2. Let's go through it a little faster. So I want to get all of my x's on one side, so I would subtract x from both sides. That's going to leave me with 3x plus 7 on the left, negative 2 on the right. Well, I want to get rid of this plus 7. What undoes adding 7? Well, subtracting 7. So we'll subtract 7 from both sides. That leaves us with 3x equals negative 9. And again, we said we could multiply both sides by 1/3. And that's going to leave us with x equals negative 3, which is what we got. Okay, so let's solve a bunch of equations here. So 4x equals 28, that's going to be example A. Well, again, we're multiplying by 4. So what I'm going to do is, I could do, and you can think about this as in two different ways. You can either multiply both sides by 1/4, or equivalently, multiplying both sides by 1/4. The same thing, we could divide both sides by 4. Those are the exact same thing. So typically, I think you'll see it written like this, more often than not. But I don't know. People will also do multiply by 1/4. It's just really a matter of choice. Either are certainly 100% correct. So, well, 4 divided by 4, that just leaves us with 1x. And 28 divided by 4 on the right, that just leaves us with 7. Okay, so the same thing. 1/5 x equals 3. So again, I could say whatever the coefficient is, I divide that by that. So 1/5, I'll take both sides and divide it by 1/5. Now, sometimes people will get a little confused with this fraction on the right side. So maybe one way that would be more natural to write it. Well, I've got this 1/5 on the left that I'm multiplying by x. Let's multiply both sides simply by 5, right? Because on the left, that'll leave me with 5/5, which is 1x. So I'll be left with x on the left side, and 3 times 5 is 15 on the right. So let's apply that same principle to part C. So again, I could divide both sides by 3/4. I could divide both sides by 3/4, or equivalently, what I could do to get rid of that fraction, that coefficient in front of x, since I'm multiplying by 3/4, what would I have to multiply both sides of this equation by so that I'm just left with x at the end? So what number would I need to multiply both sides by? And again, it's got to be the same number on both sides. Well, let's see. I've got a 3 in the numerator. If I put a 3 in the denominator, those would cancel. Well, likewise, I've got a 4 in the denominator. Let me put a 4 in the numerator. Those would cancel. That would all just leave me with x on the left side. So if I'm multiplying x by 3/4, I'm going to multiply both sides by 4/3. Okay, so that's a long way of saying that. So cancel, 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 cancel. All those factors cancel. We're left simply with 1x on the left. And we could make this 11/1. Again, we just multiply across the top. 11 times 4 is 44. 1 times 3 is 3. And just to point out, if you did do it suppose we did the division, just to point out the stuff with fractions. If we divided both sides by 3/4, how would you simplify this? Well, I would say 3/4 divided by 3/4, that's the same thing. That just leaves me with 1x. What I could do is I could think about 11 as being 11/1. And recall, if we have a fraction divided by another fraction, what we do is we leave the top fraction alone, that's 11/1, and we multiply it by the reciprocal of the denominator. So that becomes multiplication, but it flips. Right, it flips. And instead of multiplying by 3/4, we are multiplying by 4/3, which is correct. And again, that puts us right back here. So just to show you, those are both 100% correct. a matter of taste, a matter of style, and do whatever makes you happy. So d, that's 5.1x equals negative 15.3. Well, okay, I see something being multiplied by x. I don't care what number it is. It can be whatever it wants to be. I'm just going to divide both sides by it. So on the left, that doesn't take me any thought because it's the same number. That just leaves me with 1x. And well, you could put this into a calculator or do long division. We've got a negative over a positive. That's a negative. And it looks like just negative 3. Because 3 times 5 would give me the 15. And then 3 times 1 would give me the 3. So it looks like negative 15.3 divided by 5.1 would just leave us with a solution of x equals negative 3. Okay, so on the left side, again, I see two terms involving x. Just one little low number on the right side. So the first thing I would think is, well, let's combine those two terms on the left. Negative 2x plus 5x, those are like terms. So I do the arithmetic on the coefficients. Negative 2 plus 7, that's going to leave me with 5. And don't forget to attach the x. So negative 2x plus 7x, that's going to be positive 5x. If you got negative 2x's plus 7x's, you got 5x's. That still equals 14. And again, what we could do, we could divide both sides by 5, or equivalently multiply both sides by 1/5. And let me put that multiplication sign in there so that it doesn't look like some weird mixed number. We don't want that. So that's just going to leave me with x on the left, and that would leave me with 14 over 5 on the right. All right, let's look at this last one. Let's move it down. Okay, so now, oh, we've got two more. How exciting. So same thing. Now on the left side, I think, well, we've got three terms involving x. I can combine those, and then we'll just go from there. I don't really see any like terms on the right, so I'm just going to leave that alone for now. Well, we could do this in 2 steps. Let's do it in 1, because they all, right, just involve x to the first power. So just like our last example, we do the arithmetic on the coefficients. So I'm thinking about 3 minus 2 plus 8. What is 3 minus 2 plus 8? Well, if I have 3x's minus 2x's, that's going to leave me with 1x, plus 8x, that's going to leave me with 9x. So that's going to leave me with 9x on the left. Okay, I want to get all of my x's together. Again, we're going to leave the right side alone. So 9x equals 17 plus 5x. Well, I'm going to subtract 5x from both sides. On the left, 9x minus 5x, that's just 4x. I'll just be left with 17 on the right side. And now the same thing, I'm multiplying my coefficient. I'm multiplying my x, I've got this coefficient of 4. So I'm going to divide both sides by 4. And on the left, that's simply just going to leave me with 1x. And again, there's nothing to simplify. 17 over 4, you could make that a decimal, you could make it a mixed number. I just leave it alone if it doesn't reduce. So x equals 17 over 4, that would be your answer. Last but not least, oh my goodness, still the same thing. When I look at this, I see x's to the first powers floating around, and then I see just a bunch of numbers and some parentheses. So I still think this is linear, and I could solve this. The first thing that I'm going to do is get rid of these parentheses. So I'm going to do that by distributing, and oh no, we do have to deal with fractions on the left side, but that's okay. So the best for last. So 1/3 times x, well, that's just 1/3 times x. And then I would have negative, so I'm doing a positive times a negative. That's giving me my negative sign. I would have 1/3 times 7, which I can write as 7 over 1. So I'm just multiplying here and here. Well, if we multiply in the across the numerator and across the denominator, that's just going to leave us with, again, we said we've got a negative. That's just going to leave us with 1/3 x minus 7/3 when we distribute. And then still plus 2x. So I'm not doing anything with that. That's not in the parentheses, so I don't distribute the 1/3. Only to those first two terms do I distribute that 1/3. And now on the right side, well, my 5 is just hanging out. Well, again, I'm distributing negative 3. So negative 3 times x is negative 3x. And then negative 3 times a positive 4. A negative times a positive is a negative. 3 times 4 is 12. And again, the 7x is just chilling out. Okay, what can we combine? So now on the left side, I see that we have these like terms involving x. Well, I need to get common denominators. So I could think about 2x. I could think about that as being 2 over 1x. And what I could do is I could multiply the numerator and denominator of that fraction, just that fraction, by 3, right? And that's going to give me common denominators. So I've got 1/3 x. We're not doing anything with that. And I'm going to reorder as well. So I'm going to write my term, this last term, I'm going to write it next. So let's simplify. So 3 times 2, that's going to be 6 over 3 times x. And then I still have my minus 7/3. So I just simplified this and put it in the middle. And my negative 7/3, I just brought it out to the side. And again, the whole reason I did that was to get common denominators. Let's go ahead and keep simplifying the left side. We'll come back to the right side here in a second. But let's go ahead and finish this thought. So we got common denominators, 1/3 x plus 6 over 3x. Again, we add the numerators in this case. So 1 plus 6, that's going to be 7. Still over 3 times x minus 7 over 3. Yeah, that's kind of interesting. So that's going to be the left side simplified. Let's go ahead and clean up the right side as well. So I see some like terms again. I see a 5 and a negative 12, and then I see a negative 3x and a positive 7x. So if I do 5 minus 12, so I'm saying, oh, this is 5 minus 12, that's going to give me negative 7. And then I've got negative 3x plus 7x. Well, negative 3x plus 7x, that's going to give me positive 4x. Sorry, just making sure that I did something weird there. So 5 minus 12, negative 7. Negative 3x plus 7x is positive 4x. There we go. Sorry, I'm just going to drop that right down again one more time. And now we're back to like our very first examples. I want to put all the x's on one side, all the numbers on the other. Again, it doesn't matter. I'll just subtract 4x from both sides. And maybe I'll do 2 steps at once. So I'm going to subtract 4x from both sides. That's going to give me only x's on the left. And I'm going to add 7/3 to the right side. So let's see if we can't do all this at once. Okay, so on the left side, I've got 7 over 3x minus 4x. That's combining, that's combining those like terms. And then, so I've got negative 7/3 plus 7/3. Those are going to cancel. And then on the right side, I've got negative 7 plus 7 over 3. So I'm just combining these two terms. And the positive 4x and the negative 4x, those both just cancel. Oh my goodness. So once again, we have fractions. Now there's a couple ways to do it. Again, we could get common denominators and simplify and go from there. Let's just make another little observation that comes in useful. Let's use this multiplication property. So again, what I can do is I can multiply both sides by any number that I want. Any number that I want. What might be a good number to multiply both sides by? Again, it's got to be the same number, so I'm going to multiply by some number here and some number here, so that I get rid of my fractions. That's another way to do this. So we'll apply that in this case. And it looks like to me, if we multiply both sides by 3, when I distribute, I can get rid of fractions. Because when I multiply 3 times 7 over 3, the 3 over 3 would cancel, and that would leave me with just 7x. Or equivalently, we would get 21 over 3x when I distribute. which again is just 7x. And when I distribute, that's going to be negative 12x. And then on the right side, 3 times negative 7, that's negative 4. The 3 times the positive 7 over 3 will just leave me with positive 7. We're getting close. On the left side, 7x minus 12x is negative 5x. On the right, negative 4 plus 7 is positive 3. Again, we can now divide both sides by that coefficient, which is going to be negative 5. Well, on the left, we're just left with x. Not much simplification on the right. We've got a positive over a negative, so I'm just going to go ahead and write that negative. And then we've got 3 over 5 as our solution. Okay, so a lot more going on in that one. Again, same basic idea. The only thing that really made this one messy is just the fractions. So certainly, if need be, maybe try this one on your own. You can always practice it and make sure that you're getting what I'm getting here at the end. But again, the same idea. You're just trying to condense, get rid of parentheses, condense. Maybe there's some arithmetic headaches. But again, what I'm really trying to illustrate is that the process is the same in all of these. So, all right, I hope this helps. This makes some sense. You will absolutely use this property, this multiplication property, all